Hey guys, so in the last video we talked about heat engine, and in this video we'll talk about heat pump. Well, both are having very good relationship. Well, the diagram of heat engine and heat pump is almost same, but intention of using heat pump is different. Why I'm saying this, let me tell you. So two key points you need to remember whenever you are studying heat pump. It is reversed of heat engine, right? Reversed of heat engine. How? I will show you through diagram. And second point is what? It is a non-spontaneous process. Non-spontaneous process. So there are two types of processes we study. One is spontaneous and another one is what? Non-spontaneous. So let me make you understand why I am saying it is reversed heat engine. That is very important for us to understand, right? So okay, in case of heat engine, what we do basically, we use like this. We are having temperature T1, this is higher temperature, lower temperature, this is QH and this is QL. We are using arrow downward direction, right? But it is reversed. In case of heat pump, it is reversed. So what will happen? Direction will change. In case of heat engine, we got work output, but in this case we will give what? Work input. So this is the difference between heat pump and heat engine, right? In case of heat pump, our desired effect is to get higher temperature, right? But in case of heat engine, our desired effect is to get work output. This is the major difference between heat pump and heat engine. I hope you understand. Now, in case of heat pump, let's talk about heat pump. In case of heat pump, this TH is known as what? This one is sink and this one is source. It is going in the opposite direction, right? It is going in the opposite direction. That is because of external input in the form of work, right? That's why it is going in the opposite direction, right? It is opposite of second law of thermodynamics, you can say, because temperature is not flowing from higher temperature to lower temperature. Here temperature is flowing from lower temperature to higher temperature. Here lower temperature is source and higher temperature is what? Sink. And that is our desired effect. Now here come, my dear, we have studied efficiency so far. In case of all the work producing devices, we used efficiency. For all the work producing devices, we used term efficiency. That is, example, let's say heat engine. But look at this diagram. Is it work producing device? No, it is work absorbing device. So for work absorbing device, what we find out? COP, right? Like heat pump is a work absorbing device, like refrigerator is a work absorbing device. So in this case we used COP and in this case we used efficiency. The major difference between COP and efficiency is that COP can be greater than 1, but efficiency cannot be, impossible to get greater than 1. It can be equal to 1, which is again ideal condition. We cannot get it. Practically it is not possible. So efficiency is always what? Less than 1. But heat pump can be greater than 1, right? Can be less than 1 also. There are few cases, but can be greater than 1, right? Now, so here we will find out COP, right? Let me write down. So we'll find out what? COP. So COP is equal to what? Desired effect upon work input. So here what we got, the desired effect, that is QH by W. Alright, I hope you got my point. Now what we can write basically, if you want to write in terms of first law of thermodynamics, in terms of first law, what we can write basically, that is what we can write, summation of Q for a cycle is equal to summation of W, right? From first law, consequences of first law of thermodynamics, we got this, right? The summation of Q is equal to summation of W, right? Even from this, what we can apply basically first law like this: W plus QL is equal to QH, because two are input, one is output. Work is input, QL is input, and output is what? QH. So from here, what we can write, basically, W is equal to QH minus QL, right? So in the place of W, we can write here QH by QH minus QL. This is the formula for finding out COP of heat pump in terms of heat. But if you are talking about how we can able to find out in terms of temperature, then it will be like this: COP of heat pump is equal to TH by TH minus TL. Well, if you have given question in examination, they are telling you to find out COP by using they have given values of heat as well as temperature, then you can consider heat first, because through heat we can get actual COP, through temperature we can get maximum COP, right? Now let's understand the relationship between heat pump and heat engine, because these two are really important to understand. So maybe if you remember, the efficiency is equal to what? QH minus QL by QH. But here it is in the reverse condition. That is why it is known as what? Reversed. It is reversed of heat engine, because efficiency, and but yeah, term is different, COP, because in case of work absorbing device we consider COP, in case of work producing device we consider efficiency. So what relationship we can build from here, right? It is very important. Please remember this: COP of heat pump is equal to 1 by efficiency of heat engine. Even this relationship will continue with whenever we'll do refrigerator also. That will be definitely help you a lot to understand the concept. Even that relationship is very useful for solving numerical problem, especially complete examination. Doesn't matter what, this is very simple, not that much difficult, but you have to practice. And whenever you are solving numerical problem, whether it is heat engine or heat pump, even refrigerator, always draw diagram and put the values you have given. Always look at the unit also, which is really important for solving numerical problem right way without making any silly mistake. Thank you very much. Like, share and comment. New to the channel, do subscribe. God bless you all. Bye bye.